What we should have observed about the roots in the above examples, that's the examples that preceded this note, that when the coefficients of the equation are all real, the roots occur as a conjugate pair. That's, of course, any complex roots we have. When the coefficients are not real, we cannot guarantee this. However, when solving equations with real coefficients, we can use this fact. If we know one complex root, then another complex root must be the conjugate of the root we know. So if we knew that z was 3 plus 2i, was a root of our polynomial, then we'd also know that 3 minus 2i is a root. If we are solving a cubic equation with real coefficients, we may have the following situations. 3 distinct real roots, 2 real coincident roots, and a third distinct root, 3 coincident real roots, 1 real root, and a complex conjugate pair. And of course, in the exam, very often you're looking at this last case. Note, it is not possible for a cubic equation to have no real roots, as if you consider the shape of the graph, it has to cross the axis somewhere. So we have some different situations here. 3 distinct real roots, a repeated root, and then a distinct one over here. This one here seems to have coincident roots. Everything happens there. But this one here would have the one real root and then a conjugate pair. When solving a cubic or higher order equation, we can use the factor theorem to find one or more roots with the aim of leaving ourselves with a quadratic, and then solve the remaining quadratic by factorization, the formula, or completing the square.